Hello and welcome to our lesson on radicals, adding and subtracting rational expressions. First, let's talk some definitions. A radical expression, no equal sign, is an expression that includes a number and it can include the variable, a radical or root sign, and an index. Remember, the index is the tiny number. The radicand includes a coefficient, a variable, and an exponent, potentially, and then also there's your radical sign. Adding and subtracting of radical expressions absolutely must be done with like terms. You cannot add or subtract terms that are not similar to each other. So, take a look at this one. Are they like terms? I've got an x cubed and an x cubed, and then I've got a 10 and a 6. The 10 is fully rationalized. In other words, it's fully simplified. 5 times 2. Can't be reduced any further, and 3 times 2 is 6. So the coefficients don't match. These would not be like terms. There would be no way that we could add or subtract them. So we would consider these not like terms, and you would just leave that as a final answer. Let's look at the next one. I've got y to the 27th, y to the 27th, and they're both cubic root. Those are exactly the same as far as the terms go. They're like terms, so we can go ahead and add or subtract. First of all, you need to make sure that you've fully simplified under the radical. Turns out y to the 27th is not fully simplified. And if you remember the shortcut, what it's actually asking you is, if you have 27 y's, how many groups of 3 go into 27? Turns out 9 groups, because 9 times 3 is 27, and you don't have any leftovers. So what that means is we get to take out 9 groups of y. There's the cube root, and there's nothing left over, so that means if there's nothing left over, we actually don't even need to write the square root sign or the cube root sign. Here you've got minus and negative. What does minus and negative mean? It's negative times negative, and when two of them collide, they turn positive. So let's keep that in mind for later. Now again, you've got y to the 27th. How many groups of 3, because it's the index of 3, go into 27? 9 groups. So we're actually going to take out, we've got our 2x squared, and then we're going to multiply that by y to the 9th. Again, that took out everything under there, so we don't need the radical sign anymore. And then remember, two of them collide with negatives, you've got a positive, so you actually have y to the 9th plus 2x squared y to the 9th. Now, are these like terms? Can we add them? I've got a y to the 9th, and then I've got x squared y to the 9th. They're not like terms, so this would be written as my final answer. I can't add them any further than that because they're not like terms. Here, we've got z to the 16th and z to the 14th. Let's see if that's going to work. If we have 16 of those z's and the index is 2, they're actually asking how many pairs can go into 16. 8. And 8 times 2 is 16, so we don't have any leftovers, which means I can take out, negative comes from the original, I can take out 8 pairs of z, and I'm left with 24 under the radical. So far, so good. Let's look at this. I've got 14 pairs. Well, what's 14 divided by 2? It's 7, with no leftovers. So I have plus 3m z to the 7th. And then I still have radical 5. These don't match, however, we still haven't fully reduced 24. So let's try to simplify it, and we'll use the factor tree. 24 is 4 times 6, and then we've got 2, 2, 2, and 3. Pairs come out, singles stay in, so I've got negative 2 times z to the 8th, and then I've got radical, and my two lonely leftovers have to go back in there, and they have to be multiplied, so it's 6, plus 3m z to the 7th, radical 5. The radicals don't match. These aren't considered like terms. This is going to be your final answer. You fully reduced everything or simplified everything, and then that's as far as you can go. Because they're not like terms, we cannot add or subtract them. Let's look here. I've got 35 m to the 10th and 4m to the 10th. Let's take a look at our exponents first. We've got 10, and Our index is 4. So they're asking us, how many groups of 4 can we find in 10? Well, 2 times 4 is 8. We have 2 left over. So this leftover ones can't go in evenly, they can't group up, so they need to go back under the radical sign. The full groupings get to come out. So it turns out that we can take out m squared. And what's left is the 35m, and then those 2 leftovers who couldn't group go back under. Now we've got 0.5x, same thing over there, you've got m squared, we're looking to the 4th root, and then we've got 4m squared. Have we fully reduced everything? I don't think so. There's a 4 there. Radical 4? There's a 35 there. Radical 35. But the problem is we're looking for the 4th root. 2 times 2 is 4. That means we have a pair of 2's, but we don't have 4 of them. And 7 times 5 is 35. That's the only factors, and there's definitely not a group of 4. That's as far as we can go. These are not like terms, which means your final answer is this. Remember, they have to be like terms underneath the radical in order for you to combine them, and they're not, so we can't do anything with that. So when we're adding or subtracting rational expressions, only combine like terms. They have to look exactly the same. Keep the whole number outside of the radical when you're adding or subtracting. We never moved any whole numbers back under the radical. The index does not change. We kept to the 4th, to the 2nd, to the 3rd, whatever it is. The index doesn't change when you combine like terms. And be sure to simplify any of those radicands, which is what we had to do to figure out if we had like terms or not. Plus, if we did have like terms and actually were able to add or subtract, at the very end you have to make sure that everything is fully simplified. And that's it for our lesson on radicals, adding and subtracting rational expressions.